Okay, so let's continue our discussion on the dictionaries, and then we're going to talk about sets and files today. All right. So we were talking about dictionaries in the previous lecture, and we looked at initializing dictionaries, adding values to the dictionaries, removing values to the dictionaries, adding two dictionaries together. Okay. And in this section, the one part that was remaining was the nested dictionaries. So today I'm going to start the discussion with nested dictionaries. Sorry. So dictionaries, as we know, can be nested at any level, to any level, and then we're going to do that right now. Suppose let's create a dictionary. Suppose there is a dictionary called um, D, which is an empty dictionary at the moment. And suppose I'm going to add a name in this dictionary, and I'm going to say, okay, name equals to, let's say, my name. So now dictionary becomes this. Now let's add some contact numbers. Okay, suppose there's a key called contacts in this dictionary, and this key, the value is a list. So instead of storing a string, we are storing a list for this, for as a value for this particular key. Suppose the value is we are storing some kind of a number, let's say phone number, or let's say something like that, and maybe one more number. So now the dictionary has a key name. It has a key called contacts, which is a list, and that list contains some items in it. And let's finally add maybe another dictionary here. Suppose I'm going to add another key here, and this key is called address. And the address key contains the value for this is another dictionary that's represented by this. And suppose we're going to call this as, let's say, street is the key, and the value is, let's say, 123 coding way. We call this city equals to, let's say, San Jose. Now this dictionary has a name, context, and the third key is address, which is another dictionary in it. So this allows you to structure your data in some way, right? So if I say for each key in D, print k comma D of k, so then you will get key value pairs in this way. And with this level of with level of nesting, you can always uh, reference things in uh, by indexing further and further. So suppose you say D of, this is your dictionary. So if you write, let's say, D of name, then you get, say, Himanshu. And then you can say D of address. And then if you want to say, let's say, the city in this address, then you can further index this. But this results in a dictionary. This is a dictionary. And then you can further ask for one more key, let's say city. That gives you San Jose. So you can nest the dictionaries further in this way. If, let's say, you were modeling some kind of a system, let's say you were modeling some students, then essentially what this can be is you have a student dictionary in which each student is, let's say, has an ID, okay, the which has some kind of a value. Let's say the ID is, let's say, 1234. And this value is the record of the student. Let's say what is the first name of the student, which is another dictionary, and what is the last name of the student, what is the address of the student, and so on. And then there can be another ID, let's say 1235, which is, let's say, another dictionary, which has a different first name, last name, and all like that. So you can model your data by creating this type of a structure. Many applications use JSON data. So JSON, Python allows you to cast the JSON back to the dictionary directly, which we will see later on in the advanced concepts. But essentially, yeah, you can give some structure to your data in this way. Any questions? All right. So essentially, you have a nested dictionary, and that's pretty much it. So this is all I had for dictionaries. Let's move on to the next couple of uh, structures that I want to talk about. The first is set. Set is pretty similar to dictionaries. The only difference is that there is no value associated with the keys. Set is a dictionary that essentially has just the keys. Now, what are sets? In mathematics, you may have dealt with sets. So sets are basically a collection of distinct items. They are represented by similar curly braces. And all you have is some kind of a value here. So you say value 1, value 2, and like that. And they're used as a, like, you can use it as a caching mechanism, or there are some uh, interesting use cases for sets as well, that as we'll see. So the first thing is creation of the sets. How do you create a set? There are multiple ways again to create a set. The simplest is to say s equals to set. Now this is a type of declaration that you have not seen yet, but for the first time we are seeing that we are initializing an object of a class. We are saying s equals to a set. Now you write s, you get a set. You can just directly initialize this by casting something, some iterable into a set. Suppose I say my name. Let's keep it all lowercase. Now, if you look at S, that is the set at the moment. Notice certain things here. The first thing is, if you, give me a second. If you look at it, H here is only present once. This name has H thrice, 1, 2, and 3. Right? So when you cast something to a dictionary, to a set, remember the set is a collection of distinct items. If that item is already present in the set, then there is nothing further to do. So that you only keep one copy of each item. So this is basically all the distinct elements in a string right now. So that is one way of creating a set. There's another simple way of creating a set. If you want to initialize a set with some certain things, you can just use the curly braces and say some items, like let's say A, comma B. That is also okay. Now this is a set. So that's the initialization part of set. I'll give you a minute if you want to try this out yourself, and then I will move forward. So if you try to store an item again, then set will say, okay, this H is already present. So nothing needs to be done at that point.
So it will return the same set, or
Yeah,
will it?
it will be the same set. Yes. So I'll just let you in on a function right now. Suppose this is a set and the function is called, let's say, add. You can add an item. If you say s.add a again, then set remains same. If you say set.add c, then the set increases by one count.
Just one quick thing. Can you repeat on how a set is ordered?
I'll talk about it. I'll talk about it now.
Okay.
I've not talked about it
So
yet.
are the sets mutable? I guess so.
Sets are mutable, yes. Because you're changing this object in place, yes. So let's come to so I just wanted to give you a quick idea on how sets look, but let's look into some further definition before we move forward. So sets are unordered collections. Collection of items. Okay. That means set will not remember any type of ordering that neither the left to right order of the elements or neither the insertion order. So in the case of dictionary from Python 3.7, the dictionary remembered, okay, your insertion order, but sets are not like that. Sets will store the data the way they want to store. Okay, the only thing sets are meant for is to insert an item or to look up an item, to delete an item. Now there are more operations, but we will look into it shortly. But sets will store the data in however format they want. So even here, if you notice, this is being stored this way. This is not necessarily in any sorted order, not in the left to right order. It's just stored like that. Now you can ask this question from this set that if A in S, you'll get an answer that yes, this item is present in the set.
So what's a scenario that we would want to use a set over a dictionary or a list?
Many scenarios. There are, we'll cover in the question. So suppose there are certain things that you just want to find, let's say, distinct elements in a structure. Then what is the point of a dictionary? Dictionary can solve the problem, but it's not needed. Many of the algorithms require you to keep, let's say, just a cache of something that you have seen something. Right? So when you're, let's say, in graph algorithms, for example, when you're visiting different nodes, you want to just make sure that you have already not visited this. So whenever you are done, you store that node in a set to come back and check. So that is one scenario. Now sets can also do other operations, which actually technically dictionaries can also do now. But I'll come to those operations right now. So anytime you need a cache, basically just to remember that you have visited something. Suppose there is a string, which is a long string. Okay, X, Y, Z, A, B, C, X, A, B, Y, Z, and something is going on. And you want to find out all the distinct elements that are present in this string. Then all you need to do is, as you move along, you just need to store these items in set. And on each iteration, you can just check whether that item is present in the set or not. If it's present, then you don't need to do anything. Right? So set are used in that way. Now dictionary can also be used. You can just create a dictionary with some key and a value pair. Now this value is redundant. It's not needed at the moment because all you're checking is whether this is present or not.
So when you defined a set, you said it's a dictionary with just keys. And
I just said it, but yeah, it's just a way of saying, yeah.
Yeah, and it's a it has only distinct elements.
Yes.
Why can we define it as a list with distinct elements?
Why do you want to do that?
Because to me, it seems that it is more closer to the list since it has only one item and it's not coming in a key value pair.
I mean, the purpose of a set is to, once again, per set consists of distinct elements.
Yes.
That is the purpose of it. I mean, if you want, let's say, duplicated items, you can create a list.
So my question is that dictionary is key value pair. List
Yes.
is single element. Set is also a single element.
Yes.
So saying that it's a list with distinct items, would that be a more precise definition of set?
Lists are ordered collections. Just keep that in mind.
Okay.
Sets are not ordered collections.
Yeah.
Yeah. And secondly, list, see, fundamentally as well, if you notice, the list stores data in contiguous blocks of memory. So list essentially is an array where if the size is 10, then essentially these items are stored like this. Whereas a set, the items may be anywhere in the memory. So you have, let's say, A, B, A may be somewhere, B may be somewhere. You find out whether an item is present or not by hashing that item and checking what is if something is present or not.
Got it.
So they are internally different.
Got it.
So let's look at some of the functions of set. Now, one catch here. Let's say you think this may happen. Let's say you want to, let's say, define a set in your program and you say, okay, I'm creating an empty set. Later on, I'm going to say s.add 5. This will be an error. If you define it like this, then Python thinks that this is a dictionary now. And you cannot add items in dictionary like this, like just an item. So it will say that the dictionary object has no attributes. So keep that in mind. So when you define an empty set, you have to do it like this. But if you have already initialized a set this way, let's say 1, 3, 5, then you can write s.add, let's say 6, then it's fine. So there is a little bit of this kind of catch there. When an empty set is created, it has to be done this way, always. All right, so let's look at some of the set things further. So let's look at dir of set. Okay, you have some kind of a union, update, pop, remove. Let's look at some of these functions real quick. Suppose you have a set. You want to add an item. You can just write set.add, something like a 10. If you want to remove an item, you can write set.remove 6. That item is gone from the set. Now, in mathematics, if you have dealt with sets, there are few things that sets let you do. Suppose you have a set with certain items. Suppose names, or you can say something like tennis. So these are the, let's say, people who play tennis, X, Y, Z, or A, B, C. And let's say there is another group, which is, let's say, baseball. And then there are certain people who are playing this, let's say, X, D, F, G, and A. If you want to ask a question, find all the people who are playing tennis and baseball, both. Right? So that is referred to as an intersection. So you can intersect these two sets and you can find the common elements in one shot. So this will return x, which because x is common, and I think a is common. So this type of operation where you want to intersect two different things, or you want to find the union of the two things, you want to say find all the people who are playing either tennis or baseball, then what you are trying to do is you're trying to do a union in this case. So this will result in a set that has all the items here and all the items here. And of course, if x is there once, it will not be again. So it will not duplicate. So it will have everything, say x, y, d, a, c, c, b, g, and f. You can ask different other questions. You can say everything that's in A but not in B. So let's do some of these operations. Suppose you have set of this 1, 3, 5, 10. Let's call this S1. And let's have another set. S2 equals to something like, let's say 1, 1, 4, 9, and something like, let's say 5. So if you want to do the union of two things, to these sets, you can write S1 union S2. That gives you the union of the two sets. Or you can write S1 or S2, S1 and S2. So this gives you the intersection. So this means that the item is present in S1 and it's present in S2. So that's 1 and 5. Or you can write either it's present in S1 or in S2. Or you can write S1 minus S2. So the items that are present in S1 but exclusively present in S1 that are not present in S2. So you can get this type of answer as well. I'm going to give you a minute to try this out yourself.
I'm
Now-
curious.
Yeah.
So, regarding like after 3.7 that they made dictionaries ordered, did it? I guess there was just much more of a demand or need for that overrode the performance hit. I assume it took by allowing ordering, where sets doesn't have ordering, so it didn't. Performance was more important than ordering it.
I don't know the reason for that. I'll have to research why this happened. And I know that in dictionary, if you deal with algorithms, there are certain times where if dictionary would remember the insertion order, your life would be a little easier.
Exactly. Yes.
So in that cases, it does help.
Right. But I assume it took a performance hit by ordering it.
I doubt that it took a performance hit. Once again, I'll have to read the spec. That I'm not sure about that level of detail at the moment. But I'm pretty sure there must be a lot of stuff online about this.
Right. Yeah, just because there's really
So casting, you can cast anything, like let's say if it's string, any type of a string as we did, into a set. You can just do set of this. You get the answer. Or let's say you do set of a list. For example, you have 1, 2, 3, 4, 5, 6, 6. Then you can cast a set into a list into a set as well. Similarly, you can cast a set back to a list. You suppose you have this, and you just, let's say, put a list constructor on it, and essentially you are back with a list. So as you might have guessed, suppose this is a list, and suppose somebody says remove all the duplicates from this list. Okay, there is a list like this. Somebody says remove all the duplicates from this. So essentially what you can do is you can just simply cast it into a set and then cast it back into a list. And the duplicates are gone, essentially. Let's look at a problem. Okay. This problem is called, let's save it. It's called unique chars. So essentially, given a string, return true if all the characters in string are distinct, are unique. So if duplicate character is found, then return false. For example, Saturn, that's a true. But Frodo is false. So given a string, return true if all the characters in the string are unique. If they are duplicate, then you return a false. How do we do that? So suppose I'm going to define a function, unique
I have
chars.
an idea.
What is that?
I have an idea. You have to use the length function and compare.
So that's that's certainly one technique that you can do. So what you can do is you can compute the length of the string, and then you can compute the length of the set that comes back from the string, and if they are different, then you know that there are duplicates. Suppose that name is equals to Frodo, then len of name is going to be 5. And if you construct a set from the name and then put a len on it, then that will be 4 because this O is duplicated. So you can find that out this way. Yeah, so in this case, suppose you define a function def unique chars, then you can do this way. You can just compute this.
One quick question. When you cast a character array or any array into set, does it change the length or does it change the order of the array, like elements?
Yes, it does. It does.
Thank you.
So essentially what you can do is you can just say, okay, S is a set, and you can just go from left to right. You can say for each item in S. So here's the algorithm to do this. Now, why am I going to do this way? I'll just tell you in a second. So suppose there is a string which is called, let's say, Frodo. So first I'm going to initialize some kind of a set. Then I'm going to go in the string from left to right. Each item, I will check whether it's present in this set or no. If it is not present, that means we have not seen that item yet, and we can store that item in the set. So we continue going this way. This is FR and then O. So we keep storing these items in the set. When we reach the last O, we will check if that item is present in the set. If it's present in the set, then this tells us that this element was found already in the past, and hence there's a duplicate character, and we can just return the false. So if you want to code that, then basically it's kind of similar to dictionaries, and you can do this in dictionaries as well, but essentially we'll do this way. For X and S, essentially if X not in S, then S dot add X. Else, if this X is already present, then return false. And if you reach the end, then return true. So you can just call this unique chars.
But if you want to know which item was repeated, you have to use a dictionary.
Not necessarily. Let's say you're returning a false, you can return the item here as well, right? Whatever is the duplicate item you have found.
Ah.
With the luxury with the duplicate is that if only one copy is present, then you're good. So let's just say Frodo, and let's run this. So this is what happened here, true and true. Why did this fail?
You have two S, S as a string and S as a set as well.
Oh my God. Okay. Let's just call this S and let's call it, no, let's just call this input. Thank you. Thank you for catching this. So for X in input, if X in set, then do this. Okay, this should be good. Let's run this. And then you get true and false. Now I tend to do things this way. Okay. Because once again, when you're preparing, let's say from the interview perspective, then you have to worry about the space complexity. You can do this in a simpler way as well, right? You can just do this comparison. You can say, let's just define another function here real quick. You can say unique chars 2. You can just say set of input. If the len of set of input is not equals to, or is equals to len of input, you can just return that answer. So you cast this into a set and then you compute the length. If that length is equals to length of the input, then essentially you have distinct elements. Otherwise you don't have distinct elements. So you can just similarly run this on the 2 and you get the answer. But what will happen is that if, let's say, once again, this is only relevant for interviews, and let's say you're working with very large data set, is that what if this string is too big? Then you don't want to cast the whole thing first. You want to go in this way so that you, as soon as the problem is found, you can return the answer then and there.
So the second one would be at least two loops. I don't even know what len does under the hood. So set will loop through every character.
No, the len gives you an over time. So len probably is an attribute that is just keeping track of the size of that array at any time.
Okay.
It doesn't have to loop through to give you the answer.
Yeah, I'm talking about the set on both sides.
Yeah, so this set.
Oh,
yes.
It's only one time. Yeah.
Yeah, one time, and yeah, this will be a linear operation.
Okay.
Depending on the size of the input, that big of a set will have to be constructed.
Mm-hmm.
But yeah, you can use it this way. Now, if you deal with graphs and you deal with BFS and DFS, then you use set there a lot to keep track of all the nodes that you've already visited. I'm going to put some problems on the GitHub for the sets that you guys can check out.
I mean, they're both linear time solutions, except the first one the best case could be much, much faster if it's early.
That's right. This is going to fail as soon as the first element is found. Yeah. This is blindly going to convert everything to set first.
Right. It'll definitely traverse through everything.
If, let's say, you are working in your office and you have to writing some kind of a script and you want to do this work, this works fine. There is no problem. Right? There's no worry if your automation is not going to suffer because of this. But if you're working on very large set of data or you're having like an interview type of situation, then this becomes important to understand like what this operation will entail. This will always be worst time in that case. The last section I want to talk today is files. Before that, so last topic for today I want to talk about is files. Okay. There is Files are important, and there are few things that we want to talk about uh, in context to files. First is to how to read a file. Now, files are something that are on your hard drive. So you will have to specify the location where the files are present and read them. Python provides you a library, like some built-in functions to help you with that. Second is you want to write to a file. And then in the writing the file, you either create a new file, or you can say overwrite a file, or you can append to a file. We're going to look into these three operations here. And the files that we are dealing with are text files at the moment. Okay, not the binary files for now. So you can read a file, you can write to a file, and you can, while writing, you can overwrite an existing file or you can append to a file. And how this is done is with a built-in called open. Okay, so let's do this. Let me go to, let's say, the downloads directory in my computer. And suppose I'm going to pick a file which is called, let's say, this guy, charcount.py. Suppose, let me just see what is in there. Okay, there's a file called charcount.py. And I'm going to open this file from Python program. So there's a built-in call open. Open takes the first argument as a string, is basically path to file. And the second argument is the mode argument. In the first argument, you tell where this file is located. Okay. We are going to use,
Question.
yeah.
Can it be a URL too? Passed to the to file, or
This can be a URL too, yes.
okay.
Yeah. So this is going to open a file, and the mode specifies what mode you're going to open this in. So the mode can be read or write, or let's say an append. So we are going to use absolute paths. There is a way to use, relative paths of course work, but there is a third way in which you tell path to your system and then the file can be looked up. But we are focusing on absolute path and relative path for now. The simplest way to open a file, I'm going to say, okay, open this file, which was the charcount.py, this one. So first I'm going to find out the directory where this is. It's located here. And then I'm going to say, okay, what is the name of the file? And we put it here. And then I'm going to specify a mode. Let's say the mode is read mode. When I hit enter, I get a file, something I get back, which is some kind of a handle on this file now. Now what open returns is, this returns back a iterator, which is a file iterator. And we will see how it works. So you can assign this operation to, let's say, a file, F. Now, there are multiple things you can do here. Let's say you say f.read. Then this essentially reads the entire file in one shot. And you can capture that in a string. However, if you do read right now, it will not return anything. Why it's not returning anything? Because your iterator has reached the end of the file. You need to reinitialize it. Suppose there is a file. You call open on it. So this returns an iterator back. You call it f, and this f is pointing to the very first line of this file now. There are various ways in which you can read the items of this file. But if you say f.read, that essentially will read the entire file and the iterator will reach the end of the file. Now, if you do f.read again, there is nothing to show because you have already reached the end. So you have to reinitialize this by doing this. Now I will say f.read and I'll assign it to, let's say, some string, s equals to that. So s becomes this string now. Once again, I'm going to reassign this and say f.readLine. There is a read line, if I'm not mistaken. Yes. So this is going to read one line at a time. So what are the important methods? When you have a file handle of this type, or you can say file iterator, there is a read method which can read the entire file. Then there is a read line method that can read line by line. And then there is a read lines method that will read all the lines into a list. So if I say f.read lines, then all the files are now available. See, all the text of the file is now available in the form of a list, and each item of the list is one line of a file. And we determine line by this \n. So I'm going to give you a minute to try this out yourself before I move forward. Okay, try the f read line. All right, let's try an experiment. Now I'm going to create two file iterators. Suppose one is f1 and another one is f2. And on the f1, I say, okay, read line. f1 read line. So we are here. If I do f2.read line, what do you guys think will happen?
It'll read the whole file.
It will read the whole file. I'm just saying a read line on f2.
Read line. Okay. I guess the next line of.
So it will read the file from the beginning. So the point I was trying to make is that multiple iterators can be in multiple positions within a file. So if you have a file, you have two iterators, f1 and f2. Both are at the beginning. Now, if you do f1.readLine, it will come here. But this guy is still here. So if you do f2.readLine, it will still read the first line. If you keep calling f1.readLine, then f1 is gonna reach towards the end of the file, but f2 is unaffected by it. So keep that in mind. So I'm going to write a program in which I'm going to read a file. Okay, let's use Thorny for that. And then I'm going to show you the easiest way to read a file after this. So suppose that you have, first we are going to create a file iterator, and I'm just going to copy the code from here. And let's say I'm going to say f.readLines and assign it to some kind of an array or list. Okay. And let's say this list is called lines. And later on, I just want to print it. So I'm going to say for line in lines, print line. That's for each line in line, or you can, if you're confusing, you can say for each x in line, print x. Let's run this, and you will get the full file printed this way. So you can just do this. Alternatively, if you don't want to do this, then also you can just essentially read the whole file again. And just say, basically, let's just comment this out, and let's say s equals to f dot read, and then print s. And then you can just read the whole file and print it.
Are you winding up with extra hard returns in the first example?
Can you repeat again?
I'm just wondering in the first example if each print line is adding an extra hard return.
Yes, that's right. Yeah, that's a good observation. Yes, it is adding an extra character in the end, so which is why you see it's more spaced. So you can fix that by changing the behavior of print. You can say that instead of this, end should be equals to this. So now the lines, whatever the new line characters on the lines are, they are the only one taking effect. Now, given this file iterator is an iterator, you can loop through it. So let me just create a new file, and let's just call, say, file iterate.py. The easiest way to write a for loop, just like any other for loop, is to basically say for line in f, printf, print line. So now this f is the file iterator, and you're saying for each line in f. So essentially you're going to loop through the whole file, and this will return a new line every single time. So you run this and you can iterate. Right, so 3 ways to read stuff.
Is there a way to iterate over each character instead of each line?
You will have to then iterate over this again, this stuff here.
So by default, it's line.
Is by default it's line, yes. That's the delimiter. So you have read line or read lines. This returns a list of all the lines, line 1, line 2, line 3. Or you can do iterate, you can say for line in f and do whatever you want to do. In the read, you can specify some argument. You can say only read, let's say, first 100 characters. So suppose you have this, you can say f2.read first 100 characters. So it will only read the first 100 characters here. But if you don't say anything, then it will read everything. Sorry, that's one, everything. So we are a little bit ahead of time, but I'm gonna continue for maybe 10 more minutes because I want to come finish the writing part so that we can start talking about functions in the next class. The session is being recorded, so if you are getting late, you can drop off and then you can watch it later. But now the next operation is writing. So how do you write? Same thing. You open something. Suppose I'm going to create a file. This is called my file txt, and I'm going to open it in the write mode. And let's say this is it. Now I can just write f.write something like, let's say my name is Himanshu. The 19 is the 19 characters that it has written. And then you can write something like, let's say, something, whatever you want to write, doesn't matter. But once you are done writing, you have to do a f.close. So you close the file before you, this ensures that your file is actually written. So now if you go to the directory and you write ls.lrt, then basically this is the file right here. And you can write vim myfile.txt, and this is your file. So you wrote that file on your file system. It's pretty straightforward. However, notice one thing. If I do this again, I open the iterator again and I write f.write, writing again, and I do f.close, then essentially if you do look up the file again, then the old text is gone. So you're essentially creating a new file from here. The old text is completely gone. So W by default overwrites a file. If you want to append to a file, then you have to use the append mode. So you say A. Now I'm going to write again, and I'm saying, okay, trying to append text. And then you say f.close. Go back. Let's check the directory. And you see now it's appending. Suppose I'm going to do a very silly type of copy. Okay, I'm going to, let's say, read this character count file into my file. Okay, my file.txt. So here's how I'm going to do it. So this is not a good way of copying, but I'm just showing you for an example. I'm going to say input, open this in the read mode. And this, I'm going to say output equals to open the my file in write mode. Now, what are the contents of my file at the moment? The contents of my file at the moment are this. Okay, so let's write the program. I'm just going to iterate through this. Or you don't have to iterate. Basically, you can just say, okay, let's say content equals to f.read. And then basically you can write f.write, sorry, input.read, my mistake. And then you can say output.write content. Now, once again, you have to close this, output.close. So you run this program. Maybe something happened. You look at the text of my file. Now it's this. So you copied a file completely to a different file that way. You could have done the same thing with this as well. You could have just said, okay, for, let's say if this line is, if the file is huge, but I think for all the practical purposes, it does not matter. Then you could have just written a loop. You could have said for line in input, output, dot write line, and then output dot close. You could have done that way as well. Run this, and once again, I think it will be same. Finally, let's just quickly append stuff. So let's say you do this in the append way. You run this, and you come here, you check that in the end the stuff is appended. So now the file is rewritten. But for all your practical purposes, you can just read the whole file.
Is there an insert function
Insert meaning?
to say write after the first 100 characters, insert a line, and then write the rest?
You will have to write that logic yourself. So suppose, let's say after each line you want to write something, you can say output dot, output dot write some random text. Let's say this guy. So when you do that, essentially when you look at the output, you will see that after each, you have your own stuff inserted.
So for example, if you wanted to put a comment after each function, you could say after the close function text.
Then you will have to write some logic. You will have to say, okay, if this line contains a def, then you put this. So suppose that your point is that if after the function you want to put some kind of a comment, then essentially what you can do is something like this. Oh, I'm not in them. Let's say if the line in, if the function will have a def keyword, right? So you can say if def in line, then you can just write output put dot write some documentation. Let's run this. And once you go back here, check. So you will notice that there was no function here. So nothing happened, but let's just define a function. There was no function in that file, so we did not see anything, but let's just say it's called what, char count, right? Yeah. This is the file. Suppose let's just define a function, say define myfunc, and it's just say return. And let's rerun this program. Now, if you go back, you will have some documentation added before this function. I'm moving a little fast at the moment, but let me know if you have any further questions. So essentially what we have seen today is two simple things: files, how to read, and how to write. This is an important topic because we read and write files in every single program. Pretty much any logical, any reasonable program will be reading and writing to the files. And based on this, we have an assignment. And let me show you the assignment now.